Hello everyone, welcome to this session. In this session we're going to be looking at Hsrp. We're going to be looking at the configuration, and we're also going to be looking at some of its behavior. In the lab today, what we have is a virtual PC that's connected to a layer 2 switch, and we also have two routers. We can consider these as our corporate routers. Corporate router 1, corporate router 2. This will be primary router, secondary router. And in this lab, we're going to be using VLAN 100, and we're going to use the subnet 192.168.100.10/24. And we're going to assign our PC an IP address out of this subnet, and we're going to configure it to use 100.1 as its default gateway. And 100.1 is going to be the virtual IP address that floats between router 1 and router 2. And so in this lab we're going to create a group, an Hsrp group, and the primary router will be the active one, and the secondary router will be the standby one. So let's configure our PC. We're going to configure it with 100.10. subnet mask /24, and the gateway is going to be 192.168.100.1. Okay, so here we can see that this virtual PC was assigned 100.10 with a gateway of 100.1. Now we're going to configure our router. This router has no configuration, so we have a blank interface. So we're going to configure this interface with an IP address out of the 100.0/24 subnet. In this case, we're going to make it 100.2. And then our router 2, we're going to configure with an IP address as well. And this router has no configuration. And in this case, we're going to make this one 100.3/24. So right now, what we've done is we configured the PC with one IP address, 100.10. This one has 100.2 and 100.3. So what we want to configure now is we want to configure the Hsrp, and we want to configure 100.1 to be the virtual IP that floats between the two routers. So in order to do that, you configure it under the interface. In this case, gigabit 00. And we use the standby command. So whenever we configure Hsrp, the first thing you want to determine is what group number you want to use. In our case, we'll use group 100. And one thing about the group number is that it does need to match between the two routers. The group number has to be the same on both routers, otherwise it won't work. If you put this one 100 and this one 200, these two routers will think that they're in part of separate groups, and they would not become members of each other. So in this case, we'll use group 100, and then we'll use the IP command to specify the virtual IP address that we want to use. So you can see the description here. It says IP is used to set the virtual IP address. In this case, we're going to use 168.100.1. So that's going to be our virtual IP address. And so we'll do the same thing on router 2. Standby, and the group number needs to match. So we'll do 100, and then we'll use the IP command to specify the virtual IP address we want to use between between these two routers or the virtual IP address we want to use in this group. In router 1, we can see that this router now has become the active member in this group. If we look at the status, show standby brief is the command that we can use to view the current status of this node. And in here we can see that we have Hsrp configured on gigabit 00, which is part of group 100, and it has a priority of 100. 100 is the default priority for all Hsrp groups. And then this particular node, we can see that it's in the active state, and we can see that the active node is local, which means that this node, router 1, is the active member of this group. If we right here, you can see that standby is unknown. This is because router 2 was still coming up. And so if we refresh, we can see now that the standby is 100.3, which is the IP address that we configured on router 2. The virtual IP address is 100.1. And so we can also look at router 2, and we can see that it has the same information, except that in this particular case the state is standby, and that the standby is local, basically saying that this particular member, this particular router, is the standby router in group 100. But they both have the same virtual IP address, 100.1 and 100.1. So from our virtual PC, we should be able to ping 100.1, which is the gateway, and we can. So now we can take a look at what the behavior is when we bring down the active node. So what we'll do is we'll have a continuous ping going. We'll send 200 pings. So we have the ping going, and let's go ahead and shut down our active member. In order to do that, we're just going to shut down the interface. Once we shut down the interface, we can see that the interface goes down, and we can also see that the state of Hsrp, that the standby member becomes active, is an automatic switch. And we can see in our pings that we lost one ping, but it didn't recover. And so it's a very automatic switch. Whenever the primary node or the active node goes down, the standby node automatically switches and takes over the 100.1 IP address. And that's what's very powerful about Hsrp. It's automatic. So what we're going to do now is we're going to bring up router 1. When router 1 comes back up, when the interface comes back up, it will come up as a standby member, and that's the default behavior of Hsrp. Whenever you have two routers running Hsrp with the default settings, if the active member goes down and then it comes back up in the standby mode. It does not become the active node. And this is because we don't have preamp configured, and because the priority is the same for both routers. So as we can see here, the priority for this particular router is 100, which is the default, and this router is also 100. So we haven't tweaked any of the settings to force traffic to go to router 1, and we haven't really tweaked any settings so that router 1 is always the active node. And in some cases that may be the behavior that you want. You know, we may have some sort of policy within the company that we always want router 1 or our primary router to always be the active router. You know, maybe we always want router 1 to be the active router at all times. And so in order to do that, we have to configure two settings. The first is we have to configure the priority. We want the priority to be higher than 100, and we also want to configure a preempt. So let's go ahead and do that now. So we'll go into we use the standby command, and we want to set preempt for group 100. And so I want to show this here because this is important. So even though I configure preempt, we can see that the router did not become the active member of the group. And this is the expected behavior, because even though I configure preempt, it doesn't become the active member unless it has a higher priority. So in this case, because the priority is 100 for both, the router will just ignore it. It'll say, okay, well, they're both 100, so I don't have a reason to preempt it. But if we go in here and configure a higher priority, see preempt overthrows lower priority active members. So in this case, because they're both all the same, it's not going to throw it over, or it's not going to take over. And so we're going to go ahead and set the priority here to 200, because 100 is the default, so we want to make it higher. So we're going to make this side 200, and as soon as we update the priority, this router now becomes the active member. So we can see here in the logs that this node now is active for group 100. State is active. And so we'll do our pings. We have our continuous ping going. So what we're going to do now is we're going to go ahead, and we know that this is our active node. We're going to go ahead and shut it down. We're going to observe that the active member becomes router 2, and then we're going to bring router 1 back up, and we're going to observe that it becomes the active router as soon as it comes back online. And so we're going to go ahead and expand our pings, because we want to make sure that we don't have a loss of connectivity while we do these changes. So we have our ping going, and we're going to go into router 1. We're going to shut this down. As soon as I shut it down, we can see that router 2 becomes active, and our pings are continuing to go. We didn't actually lose a single ping in this particular case, and this now is our active router. State is active. And so we're going to go ahead and bring this interface back up. And as soon as I do this and the interface comes back up, we're going to see that this member now becomes active. And over here we can see that this member will go into the standby state. So we show stand by brief. This is active, and this is standby now. And if we look at our pings, we only lost a single ping, and it automatically recovered. And that's what preempt brings to the table. I mean, it basically forces router 1 to always be the active router, as long as it has a higher priority than the current active router. So I really hope that you enjoyed the session, and I hope that you found this information useful. Please leave any comments, and if you like to see videos over specific topics, please let me know. I'll definitely like to receive that feedback. And if you'd like to get notified when I post my next video, please subscribe. Thank you. Have a great day.